Okay, question 4. This is a massive area for development. So from the mock, I'd say that this is a key area. So I'm going to go over it slowly. So it says, which lens is a converging lens with the greatest power? Well, it can't be these. These are diverging lenses. So these are concave. We definitely do not want you. So now we've got a choice of 2 convex lenses. So these concave lenses, as I tried to teach, but you should have learned it in year 9. When the rays come in, they get diverged. We want converging. So one of those lenses, ray comes in, obviously that goes straight through, and then this is going to go to a focal point, or a focal, or to a specific focal length. So the next part is, which of those has the greatest power? Well, it's going to be the one with the greatest curvature. So we've singled it down to these 2, and it must be B because it's got a greater curvature. And I don't think they've not chucked anything in to tell me a difference in density of the lens or anything like that. Okay, next one. The equation relates to the power of the lens with the focal length. So this is pick one finger, or pick one flower. It says the power of the lens is 5 diopters, so 5D. And it says calculate the focal length in centimeters. So when I use this, it'll spit me my answer in meters, and then I'll have to change it to centimeters. So calculate the focal length. I can see that there. To be fair, let's just change the color. So there, and I can say that the focal length equals 1 over the power. So this is 1 over 5. That's going to equal 0.2 meters. There we go. But now I've got to change that to centimeters. So times 100 equals 20 centimeters. And I think people have improved on that a fair bit. And now for one from the mock. That was done terribly. And it's because you just didn't know. So it says determine the critical angle for the glass air boundary. Okay, so what this question is looking at is, do you know what this means? And clearly not. So what we're going to say is we're going to pick a point at the back of there, and I'm going to just draw the normal line. Now, the critical angle is, what is the angle in which when I shine a ray through, it goes along the back edge there. All right, so sort of 90 degrees on that back edge. So, 90 degrees to the normal look. And what am I going to do? Well, the first bit is I'm going to get a ray box. So there's my bulb, and I'm going to shine some rays. I'm then going to move this around, and then I can measure the angle from the normal to see what the critical angle is. All right, so I'm going to tidy that up, and I'm going to do that again. So it's asking about the critical angle. This is, and we're going to pick the back of the block, and we're going to draw the normal line. And it's what is the angle required. So I can put a ray in here, a ray in here, a ray in here. So clearly I need a protractor. And it's which of these angles will then give me a beam that goes perpendicular to the normal at the back of the block. Okay, and then whatever the beam is, so if I just get rid of these ones here, so for example, that would then be the critical angle, and I'll put theta there for the angle. So hopefully that makes sense in terms of what the critical angle is. So now I'm going to really slowly go through, and I'll do the steps. I'll draw the pictures first, and then I'll put this into here, because it says add to the diagram to help with your answer. So damn right, I'm doing that. First job, I'm going to draw in a normal 90 degrees to the back of the block. There's one mark. So drawing a normal 90 degrees to the back of the block. Next part, get a ray box. 2. Use a protractor. So I'd get a, whoops, sorry guys. I would get a protractor, and then I would measure, just saying, get a protractor. So there we go. Get yourself a protractor. Okay. We're then going to say number 3, we're going to move the block around. So move the ray box around. So we can see we're going to sweep it, shine in, shine in, shine in, shine in. Okay, the next part is, we're then just going to say, so we're going to shine it at the, move the ray box around so that it shines onto the curved surface. And then when, number 4, when we get a ray that's 90 degrees to the normal or coming out the back of the block, but I'm going to say this 90 degrees to the normal because that's what we measure all angles from, we then measure this angle here with a protractor. That's step 5. So hopefully that makes sense. So now I can just go through. Draw a normal at the back or the straight edge. I'm not writing all that, of the semicircular glass block. There we go. Please don't do that in a test though. Okay, next part, we're going to then, number 1, shine a ray with a ray box at the curved surface. Hopefully this would have helped you on your mock. Number 3, we're then going to then see when the ray exits the block 90 degrees or perpendicular to the normal. Happy with that. And then I'm going to put theta there, and I'll put actually theta C for critical angle. And then number 4, use a protractor to measure the angle, and I'm going to say in there theta C, see the diagram. Okay. So the next question we've got is a basic one about the solar system. I think this is nice and easy. It says, a long time ago we believed that Earth was at the centre. We've now proven that Sun. Give one other idea that has changed over time. Okay, well, what do we know? There's moons around planets. So there's moons orbiting planets. We didn't know that a long time ago. And there's my 1 mark. But I could literally say anything from the Earth rotates around its axis. We now know that the planets orbit the sun. We know that Pluto is no longer a planet because it hasn't cleared its local neighborhood. We know that planets do not orbit in circles. They've got slightly flattened circles called ellipses. We know that we're not the only solar system. So we've shown that there are other solar systems around other suns. We know the Earth is round and not flat, apart from a few people digging in and being idiots. We know that stars do not wander across the sky, and that there's a couple of those are galaxies. But there we go. There's an easy one. Moons orbit planets. Done.